Hi everyone. In this video, I want to talk a little bit about logarithms, and we're going to try to do our best to answer this question: what is a logarithm? So the notation that we use for logarithms is given over here. So we have log, right? So that stands for logarithm, and the b, that's a subscript here, is log base b. So we have log base b of x, and what we'd really like to know is, what does that mean? So logarithms are very closely tied to exponential functions. In fact, they are the inverse of the exponential function. So what we're going to do is we're going to go back and we're going to look at an exponential function and see if we can use it to help us understand what a logarithm is. So I'm going to take a nice familiar one, f of x equals 10 to the x. So I want to point out two things before we get started. I know that 10 squared is equal to 100. So if I plug 2 into my function f, I'm going to get an output of 100. And I know that 10 cubed is 1,000. And so if I plug in 3 into my exponential function, I'm going to get an output of 1,000. And so these are sort of benchmark numbers that we have. We're very familiar with 100 and 1,000 and how to get to them as powers of 10. But what if we have something in between? So what I'm going to do is we're going to try to answer a question that looks like this. Okay, 10 to some power that I'm going to call y. I want to know, when is this equal to an output of 150? Right, so this is a question that we have over here. 10 raised to what power is equal to 150? So I know that whatever y is, it's going to be something that's bigger than 2, because I know 10 squared is 100, and I know it's going to be smaller than 3 because, well, 10 cubed is 1,000, which is more than 150. So it's somewhere in the middle. Now, currently, I don't really have any tools to answer this type of question. We could go ahead and we could try plugging in different numbers, and I think it's a valuable exercise for you to try and do this. So if you want to, you can pause the video here and try to find a number so that 10 to that power is equal to 150. Right? So I think you'll find that it's fairly difficult, and it's incredibly difficult to get it precise. Okay, and so this is why we have our logarithm function. So it is a tool to help us answer questions like this. And so the way that I would answer this question using the logarithm is I'd say, okay, so the answer to this question, y, what we have is we have that log base 10 of 150, that's equal to y. Okay, so these two statements that I have here are joined together. So these two statements right here, log base 10 of 150 equals y, and 10 to the y is equal to 150. They're sort of pairs that go along with one another. Okay, so if I wanted to answer this question, the exponent that I have to put on 10 to get an output of 150 is this over here, is log base 10 of 150. So a logarithm is an exponent. Okay, so when I read this over here, when I read log base 10 of 150, what I'm telling myself is, well, this is the exponent, right? So this is the exponent that has to go on 10 to give me an output of 150. So in general, the way that we define a logarithm is this. We say log base b. Okay, so now we're going to do any base b. So log base b of x is equal to y. This is the same thing, right? So we would say if and only if log base b of x is equal to y, if and only if we have b raised to the power of y equal to x. Okay, so this right here is our general definition of a logarithm. Okay, so I'm going to go ahead and put it in a box for us. So log base b of x, when I say what is a logarithm, what we mean is it's an exponent, right? And it tells us what exponent we have to put on b to get an output of x. Okay, so oftentimes this is very hard to remember. And so a few years ago now, I had a student show me a nice way to remember this here. Okay, so log base b of x is equal to y. Now, if you're over here on the left and you want to remember where all the letters go over here on the right, what we do is we call this a snail method. Right? So one of the students showed me, they said, well, you start at b, and you go b to the y is equal to x. Okay, so b to the y is equal to x. Now they call it the snail method because if you add a little ears over here, you can see that this looks like a snail. Right, so cute little way to remember b to the y is equal to x. Right. So this is our basic definition of a logarithm. So what I'm going to do is I'm going to pause the video, I'm going to clean this up, and we're going to come back and we're going to look at some concrete examples and see if we can use this snail method to figure out how we can work with logarithms. All right. All right, so we're back and we have two examples here. So if we recall, we have log base b of x is equal to y if and only if b to the y is equal to x. All right, so if I come down here and I look at this first question I have here, log base 2 of 16, what I would like to know is what is that number? All right, so this is asking me a question, right? So this is saying 2 to some power is equal to 16. Right? So let's set this up and we're going to say, well, this is going to be equal to some number. I'll call it y. And what we have here is now a question, 2 to what power gives me back 16. Right? So the way to remember that is 2 to some power y is equal to 16. Okay? And then we'll put our little snail here, right? So we'll snail method this one. And then I'll write this out. So it tells me 2. So what we have is 2 to some power is equal to 16. Right, so I'm going to give us a second here to think about this. So 2 to some power is equal to 16. Well, I know 2 times 2 is 4. And if I multiply a third 2, that gives me 8. And if I multiply a fourth 2, that gets me a 16. So 2 to the fourth is equal to 16. Right, so what this tells me is that y has to be 4. Right, so if we think about this, say, well, 2 to the fourth is equal to 16. And so what I have, log base 2 of 16 is equal to 4. Okay, because 2 to the fourth is 16. The exponent that I have to put on 2 to get back to 16 is 4. So let's look at our second example here. Log base 3 of 1/9. So we'll do the same thing. We'll say, well, if I have log base 3 of 1/9, I want to know what number this is. Is it I can write it in a different form. So again, 3 to what power is equal to 1/9? So this is what you should be asking yourself. So 3 to some number as an exponent is going to give me an output of 1/9. Okay. All right, so when I think about this one, what I see here is I have a 9 in my denominator. And so the relationship between 3 and 9 is that 3 squared is 9, but it's in the denominator. So if we think back to our exponent rules, I know that making an exponent negative would give me something in the denominator. And so I know that 3 to the negative 2 is equal to 1 over 9. Okay, so 3 to some power, well, 3 to the negative 2 gives me an output of 1/9. And so what I would say over here is that if I want to know what number this is, log base 3 of 1 over 9, this is equal to negative 2. Okay. So I hope these videos help out. This is an introduction to logarithms. And so what we want to remember is that logarithms are closely tied to exponential functions. And they're a tool that help us answer the question, what power, what exponent do I have to put on a certain number, b, to get my desired output, x. And so logarithms, they act like inverse functions, and they're a tool that we can use to answer what exponent do I have to put on a particular number to get a desired output. Right, so we'll look at more videos through logarithms, and we're going to study their properties. And so we'll see a lot more videos like this. So I hope this helped out, and I'll see you next time.